So equilibrium, K. Are we good with K and Q? Or do we want to go over that again?
Let's go over that again.
K. Something like that. Okay? So, let's just say kind of the whole ice table idea.
Yeah.
I mean, I'm guessing that we'll just start at like very beginning. So if we just put A and B in, we're going this way, right?
Mm-hmm.
But as soon as we start getting C in here, we start going like this. Do you get that?
Yeah. Because
Okay.
then you'll have more.
Yeah, so this
there,
starts going
right?
this way and this starts going that way.
Okay.
Even though it is maybe favoring this way still,
Mm-hmm.
until we hit equilibrium. So we're going to start going, and then we're going to start going both ways, mainly this way. Then we'll hit equilibrium.
Once you put in enough of the reactant that the product has enough to bounce back the same amount.
Not the same amount. Well, at equilibrium it would be the same amount, or same rate going back and
same
forth.
rate.
But
Okay.
it doesn't mean we have like,
Equal concentration.
5M over here and 5M over here.
Okay.
Right? It could be like 100 versus like 0.5.
Okay.
It just depends on your reaction.
But it's just the same rate that it's going back.
Mm-hmm. Yeah, so it's just going, this is now going the same back and forth.
Okay.
So K, this is K.
Okay.
When we find the when we get to here, we measure our values because they're going to stay the same. Now, if we just leave the conditions as they are,
Yeah.
it's just going to stay there for as long as it can, right? So let's just say we get to like 6M and 5M over here, something like that.
Mm-hmm.
We just take these values, so that's like products over reactants,
Mm-hmm.
and that's our K.
Okay.
That's it. Under like this reactions conditions, right?
Mm-hmm.
So anytime we do this reaction, it'll have the same K, equilibrium
Okay.
constant. But let's say we're at this point still, and we measure the concentrations, and say it's like 7 and 4.
Mm-hmm.
We see it's not the right concentrations to be at equilibrium, right?
Yeah.
So we're dealing with Q,
Okay.
which is 4 over 7.
Okay.
So this one's gonna give us like, whatever, 1 point, or, 1 point something, 1.2. But this one's gonna give us like 0.5 something, 0.5333, something like that. So we look at it, now we say our Q, 0.533, and our K was 1.2. So which one's bigger?
Okay.
So K is bigger.
So equilibrium's bigger, right?
Uh-huh. So is our product slow or our reaction slow? At this point. Do we need
Our products are
Mhm.
low.
Our products are low. So that's why we see it going this way still, the bigger arrow. But then if we said like this was 1.5, then it would be more like
The reactants are low.
that kind of idea.
Okay.
So Q is just like we can measure somewhere at some point in the reaction and be like, okay, we're still going favoring this side of the reaction,
Okay.
right?
Yeah. That makes more sense.
Question? Good?
Yeah.
So far? So that's all, I mean, that's the only difference.
Okay.
K is just equilibrium, but Q can be like above equilibrium, or like past equilibrium, before equilibrium.
Okay. So how do you calculate the difference between K and Q when like you're given a problem? Because I know we were given a few problems where it was like this is like equilibrium.
So they give you K.
Yeah.
So the K equals 10, right?
Yeah. And then it's like they give you like concentrations and stuff, and then it's like you have to calculate Q, but it doesn't like tell you to calculate Q. You just do it to see like which way the reaction's going.
Mm-hmm.
Okay. So how would you do that if you're given the concentrations? Do you take like?
So basically, the way they would say it is like, we're doing a reaction, and it's like, and we measure the reactants and products, and we get these concentrations for them. So since it doesn't say you're at equilibrium, we assume Q. We'll just say Q for now, right?
Okay.
We solve Q, which is just products over reactants,
Yeah.
and say it equals 10. Then we say, okay, we're at equilibrium. But if it's anything else, then we have to judge whether it's favoring products or reactants.
Okay. I think I'm confused just because all of the equations are the same, like KQ, pressure, K constant, K pressure, things like that.
They're all the same.
So it's like,
So
what's the difference?
So concentration and pressure, the only difference is you're giving things in pressure concentration.
Okay. So it's the exact same thing. Like, we don't even have to like care about pressure or concentration.
So Q and K, exact same thing. The only difference is where you're at in the reaction.
Okay.
So the formula is same thing completely.
So would Q be more like initial? Like
it could be your initial.
Okay. But K wouldn't ever be initial, would it?
Probably not. Unless it didn't react, but then why would you have that?
That's true.
You know?
Yeah.
Yeah, so Q, say equilibrium's right here, and we start right here. So it's like, kind of like this.
Okay.
Right?
Yeah.
So Q, this is Q, this is Q. This could be Q, if they don't tell us we're at equilibrium.
Oh, okay.
Right? But this is only K. And then over here, we start doing like this. Like that. This is still Q. But not K.
Okay.
That's the only difference. And then for the pressures, the only difference is when you're done with pressures, when you're done with concentration. And then from there, you can do the conversion to your constant for KC.
Okay.